So for this one here, it is essentially array2, sum13, and we're returning the sum of numbers in an array, right? And returning 0 for an empty array, except the number 13, it's very unlucky, so it does not count. And numbers that come immediately after a 13 also do not count. So in other words, if you have an array, essentially add all those numbers up and return that number. But that is, of course, in normal cases. If we have a 13, for instance, we have a 13 here, not only do we skip 13, but we also skip every single number that comes after a 13. Not every single number that comes after a 13, but I think just the next number that comes immediately after 13. So hypothetically, if we had an array of, let's say, 12, 13, and 12, let's say 11 and 5, then we would obviously want to return the sum of this entire array. But we'd also not want to include 13 into that sum, nor would we want to include 11, given that 11 comes directly after 13. So since we are sort of keeping track of the sum here, we're going to have sum as a variable within which we can store our answer, which we'd like to return. We are going to iterate through or traverse through the array and look at each and every single element referenced by its index. Doing so would allow us to put some constraints here. And we're going to say, well, if we want to add each and every single element in the array, that would just be using the accumulator pattern. Nums of I will equal sum. So the first element in the array will equal sum. And then as we move on to the next element, that is prompted by I increasing by 1, we would be referencing the next index and therefore the next element. And sum would equal what sum was before, which was the previous element, plus the current element. And then we would sort of return sum after it's all said and done. And the for loop is officially now not, after the for loop sort of falsifies this condition here, which would in that case be when I is not less than nums.length. In that sense, it would be greater than or equal to. So that's completely fine, but we also want to recall that we don't want to have 13 a part of our sum. So in that case, we could say, well, if 13 or if any given element in the array does not equal 13, then and only then would be could we use the accumulator pattern. Then and only would that be safe. Otherwise, this would imply that the number is in fact 13. And in that case, we would want to, well, if you think about it, right? So if we had let's say 13, or if we had an array which has which is 14, 2, 13, 1, and 4 as the numbers here, when we come across 13, I mean, so we 14 and 2, these will be added to sum each and every iteration. So for the first iteration, sum will equal 14 because the first element in the array at the 0th index does not equal 13, and so sum will equal sum plus nums of I. And since nums of I is equal to 14, and right now sum is equal to 0, then sum itself will equal to 14. On the next iteration, when I is in fact 1, and this is, of course, I'm referring to the indexes here, which go from 0, 1, 2, 3, 4. So it goes from 0 onwards for the length of the array. So for the next iteration, when I is incremented and I is 1, it now looks at the second element, which is, of course, the first index. Then it says, well, is nums of I, does nums of I not equal to 13? In that case, it does. And so sum equals to what sum was before, which is 14, plus what 14 is now, or what nums of I is now, which is 2. And therefore, sum is, of course, now equal to 16. But of course, then we come across the second index, which refers to the third element, and we judge whether or not that is equal to 13. Since it is, we actually don't come inside this for loop, and so that number is not added to our sum accumulator. And so we are now inside this else. So if it were, in fact, equal to 13, then not only would we want to sort of bar 13 from being a part of our sum as we have here, but we'd also want to bar the number which comes immediately after it being a part of our sum. And so the way around that is to say that, okay, well, if we're at this particular index, then we would want to increment the index by 2, such that we're now looking at the number which comes immediately after the number which comes immediately after 13. And so we could just say, well, if it is 13, then we're going to do the index will equal I plus 2, such that whatever the index was at that number, which is 13, it's going to move 2 places to the right of that number and start the index from this element, so that it actually looks starting from this element. But the problem with that is you'll notice that if we had another number here, and this is of course just for demonstration purposes, but if we had another number here and we were at 13, so if nums of I does not equal to 13, then we're not going to execute what's inside this. We're not going to add that number to our sum accumulator. Otherwise, I will equal I plus 2. So otherwise, I, which is 2, will equal I plus 2. So I will equal 1, 2. I will equal the 4th index. But then again, as we come back up here, and I is equal to 4, we increment I by 1, which takes us to the next element, not the element that we want to look at. Therefore, I must be equal to I plus 1, knowing that I will eventually equal to I plus 2 when we increment I by 1 here as well. So of course our goal is to certainly increment I by 2, but we want to do it in a fashion that takes into account that if we do it twice here, it will do it one more time here, and then we would actually be incrementing I by 3. So if we do it once here, it will be done once here, and then we will start looking at the second index. So actually I can't run this obviously because I still have these guys here, and I have to actually take those out. All greens, great.